In this video, it will be a lecture over sections 2.2 and 2.3. Just as a reminder, for your test, the only thing you have to know how to do is do these steps by hand or with your TI 8384 calculator. For your project, it may be helpful for you to also know StatCrunch and Excel, but for your test, the only thing you have to know how to use is your calculator and doing these steps by hand. And this video will cover doing steps by hand and with your calculator. So in section 2.2, we're organizing quantitative data using popular displays, and these are the different types of displays we're going to have: distributions and some graphs. So in problem 33 from your textbook, we're looking at the number of televisions in a household, and the first thing we want to do is to create a frequency and a relative frequency distribution. So these are just tables describing the type of information that we have. So here we have 40 different households, and these numbers represent the number of televisions in each household. So we already have our number of televisions on the left. Our frequency, we're just going to count these options. So how many households have no TVs? There is one. And that means one tally mark, one vertical line. How many households have only one television? So it may be helpful for you to mark off each of these options just so that it's easier for you to see. So there are 14 homes that have one television, and with our tally marks, as soon as we get to 5, we do a diagonal line across. So there's your 5, 10, and 14. If we continue counting, there are 14 homes that have 2 TVs. There are 8 homes that have 3. There are 2 homes that have 4. And there is 1 home that has 5. So your relative frequency distribution takes your number of tables and it finds the corresponding percentage, the corresponding amount relative to the entire data set. So there are 40 homes they selected. So for the homes with no TVs, that will represent 1 out of 40. And we can put this in our calculator, which gives us 0.025. And if we're writing these as percentages, you just multiply your decimal by 100% to give us 2.5%. The relative frequency for homes with one television, this would be 14 out of 40, which would give us 0.35. If we're converting this to a percentage, this will be 35%. And we continue taking our frequency, dividing it by our total amount. And what one of the notes in your textbook says is that if you add up the fractional values, it should always be equal to 1, representing 100%. If you add up these decimals, since we're doing some rounding, then it might be a little off, a little different from 1%. I mean 100%. One of the type of graphs that we can use to represent discrete data is called a dot plot. So with your dot plot, you place a dot above each of your options. So we're taking the frequencies that we have here and we're just placing a dot above it. With technology, it makes it a lot easier. Doing it by hand may take a little while. So how many homes had 0 TVs? 1. How many homes had 1 TVs? We're going to need 14 dots. And this just gives you a visual representation of your data. So we can create histograms. Histograms and bar charts look very similar, but you have to remember very key things and differences. So the rectangles in a histogram touch because we're dealing with quantitative data, numbers, and numbers can fall on a number line. But in bar graphs, your rectangles do not touch. So bar graphs are for qualitative data, favorite colors, where were you born. Quantitative data, the bars do touch. If your data is discrete, meaning there are no decimals, there are no fractional values, we cannot have a partial amount of a household. For discrete data, our bars should be centered over the outcome. So how many households had no TVs? There was one. So our data should be centered over this bar. 0 should be in the middle of that bar. How many homes had one TV? There were 14. How many had 2? 14 as well. How many households had 3 TVs? 8. How many households had 4 TVs? 2. How many households had 1 TV? So this is our histogram for discrete data. Our bar should touch because the data is quantitative and our values are centered in the middle of those bars when our data is discrete. If our data is continuous, and we're going to use a different example, then there are a few steps that we have to do prior to that. One of the first things we have to do is we're going to create our frequency distribution, but we're going to group this data. And in our textbook, these are the particular steps that we use for how to group this data. This does not have to be always a step, but these are going to be the steps that we use. So first thing we need to do is we need to know where to start. And this is called our lower class limit for our first class. Your class is just a row. So the technique that the book describes is find the smallest data value in your data set and then pick a number slightly below that number. So if we look at our data set, our smallest value is 6.37. So the lower class limit of the first class, and remember your class is represented by rows, would be 6. We found the smallest number. We're picking a number slightly below it. The next thing we have to do is to find our class width. So how wide do we want these rows to be? So these are our general steps. We take our largest data value. Our largest data value is 23.59. And we subtract off the smallest data value. Our smallest data value is 6.37. And then divide by the number of classes. In this problem, they tell us we're making 6 classes for our data set. So we're going to divide this number by 6. So compute the numerator first, and then divide by 6. We're going to get approximately, that's what this symbol means, approximately 2.87. And what we're doing is rounding this value up. So rounding up is different from rounding off, which is different from rounding down. So rounding up, whatever this number is, you always take it up to the next integer. So here's the example they gave in the book. They had 0.881. Rounding this number up, it goes to 1. We have 2.87. We're going to round that up to 3. So your class width tells you how far apart the lower class limits are. So these are 3 apart. So 6 plus 3 will give us 9. 9 plus 3 gives us 12. 12 plus 3 gives us 15. 15 plus 3 gives us 18. 18 plus 3 gives us 21. So those are the lower class limits of each class. Now we need to find the upper class limit. And what we know is that these two values, the upper class limit and the lowest class limit, cannot overlap because we wouldn't know where to put the value of 9. So we need a number very close to 9, but not 9 and not higher than 9. So if we look at our data set, we have 2 digits here. We have hundredths place. So we can pick hundredths place here as well. So we can do 8.99 as our upper class limit. And since our class width is 3, that's going to be the same value or the same difference we have between these numbers as well. So this would be 11.99, 14.99, 17.99, 20.99, and 3 more than this one would give us 23.99. So, if 6 classes are to be formed, classes are rows, choose the appropriate lower class limit for the first class and the class width. Our appropriate lower class limit was 6, and our class width that we did in this step was 3. Construct our frequency distribution. Your frequency distribution counts the number of values that fall within each class. So if we go through our table and mark off corresponding numbers, there are 15 values that fall between 6 and 8.99. There are 9 values here. And there is only one number that falls between 21 and 23.99. And that is that one value. So that is our frequency distribution. We have the volume separated into classes and how many values fall within each of those ranges. Our relative frequency distribution, we take our frequency, we divide it by the total amount of values. How many values are in this chart? 35. So we could leave it as a fraction. Depends on the directions of what the problem asks. It could ask us for the number as a decimal, and they would tell us what value to round off to. It could ask us for a percentage, so we would take that decimal and multiply it by 100%. You just have to pay attention to the directions. So if your data is continuous or we want to group it, there are a couple of extra steps that you have to do prior to actually creating your graphs. So first column and third column give us our relative frequency distribution. Construct a frequency histogram of the data. When our data is continuous, our bars, the numbers should be in between the bars. And so for example, from 3 to 6, this bar represents all of the numbers from 3 to 5.99. It does not include 6. The next bar for 6 falls within the next section. So this bar is from 6 to 8.99. This next bar is 9 to 11.99. Then we have from 12 to 14.99. And I'm missing a bar. So the last one should be out here to 24. So that is our frequency histogram. Our relative frequency histogram, we would just use the percentages or the decimals instead of the frequency on this vertical axis. So your histogram is going to look about the same exact shape. So here from 6 to 8.99, remember that was 15 divided by 35, which is 0.43 or 43%. And this chart is also missing that extra bar that it needs as well. solved here. 24. Number 11, we're given a histogram and we want to answer the following questions. How many students were sampled? This is a frequency chart. So that means these numbers tell you how many values fall in each of the ranges. So when we add them all up together, 2 plus 3 plus 13 plus 42 plus, we will end up with 200. Determine your class width. Our class width is the distance or the amount of space between the lower class limits. So 70 minus 60 gives us a class width of 10. Identify the classes and their frequencies. Our classes represents our groups, and you have to be very careful since this is continuous data. They've grouped it. So this first bar is from 60 to 69. Remember, we do not include that 70. That's for the next bar. And the corresponding frequency, this is 2. We have 70 to 79. And that frequency is 3. And we would continue on. 80 to 89, frequency of 13. 90 to 99, frequency of 42, and so on all the way out. Which class has the highest frequency? The one that has the tallest bar here, 58. So that is from 100 to 109. Because remember, we do not include the number that's on the next line. Which class has the lowest frequency? The smallest bar, the smallest number. So 150 to 159. What percent of students had an IQ of at least 130? At least means a minimum of 130. So this is 8 plus 2 plus 1, which will give us 11. But remember, this is a frequency. It's not a percent. So 11 out of 200. 200 represents everybody. Just like we find relative frequencies, we take our frequency and divide it by the total amount of numbers, which will give us about 5.5%. Did any students have an IQ of 165? No. And how do we know that? Because the bar doesn't extend out to 165. The last value range is 159. Constructing a stem and leaf plot. The key about stem and leaf plots is your legend. That tells you how to put these numbers together. So a 1 in front of the bar and a 0 afterwards means this number is 10. So here in this chart we have 10. That's our first number. 1 in front, 0 behind. You have 1 and another 1, so that means the next number is 11. You have a 1 in front, a 4 in back. That means that's 14. And we continue going down the line. And for time's sake, continue doing that all the way through the last set of numbers, 61 and 62. We can also have a stem and leaf plot set up like this, where you have 2 numbers in front and 1 number in the back, and that represents 240. So in this data set, this is 240, 244, 247, 252. For the sake of time, you continue doing that for all the numbers, and the last 3 numbers would be 282, 283, and 288. So if we're looking at fat grams, the grams of fat in McDonald's breakfast, then as you see here, all the numbers are in order. So that's the same thing we're going to do here. And what we should see is that we have a 3 and a 9. So in our legend, you always have to have a legend. 0 in front and 3 behind gives us just the number 3. And if you look, our highest number is 5. So that's going to be the last in our list. Sometimes you will see it written as stem here and leaf here. And looking at your chart, these numbers are in order as well. So it may help you to put the numbers in order first from least to greatest and then create your stem and leaf plot. So we have a 3 and a 9. For 1, we have 12, 16, 11, 16, and make sure your numbers are in order. And continue on. So here's our completed stem and leaf plot. In order for your stem, the leaves are also in order from least to greatest. What if a value is missing? Then what we would do is we would put that number there, but we just wouldn't put a number behind it. And I'm just making up an example here. So that means we'd have 15, 26, 27, 47, 47, and 48. We would just leave this one blank. You would not put a 0 behind it because that would mean 30. Identifying the shapes of distributions. Uniform means you have the same frequency all the way across. Bell shape, it looks like a bell. Skewed right, you have a skinny tail on the right hand side. Skewed left, you have a skinny tail on the left hand side. So when you have to interpret these, you have to think about creating your own scale. And frequency is always going to be on the vertical side. So if you look at number 13A, annual household incomes of the United States. So this would be incomes. And you have to think about, let's say this is $0, $50,000, $100,000. And you think about everybody in the United States. Well, there will probably be a lot more people who make 50,000 than there are that make more than that. And if you had more space, you're talking about a million, 2 million. There are a lot fewer people that make millions of dollars. So 13A would be skewed right. There are a lot less people who are on this side making a lot of money. Ages of patients diagnosed with Alzheimer's also would be, this would be skewed left. So let's draw a graph. Remember, frequency is always on the vertical axis. So here are your ages. So let's say 0, 40, 80. People who are diagnosed with Alzheimer's normally are in the upper age bracket. So there are more people, a higher frequency of people diagnosed there than on this side. So this would be skewed left. There are less people on the left-hand side who are diagnosed with Alzheimer's for 13D. Time series graphs. You're looking at what's happening over a specific amount of time. And one good representation of this would be for all my business students. And any company, you can look and see how their stocks are doing over a long period of time. So in the news, they've been talking about Apple being down, their stock prices being down lately. So that's why I chose this one. and you have lots of different options of how you can look at the data. So if we're looking at one day, it looks like there's a tremendous growth. If we look at 5 days, 1 month, 3 months, year to date, 1 year, 3 years, 5 years, 10 years. So in the grand scheme of things, the company is still doing very well. It still has more of an increase, which would lead us to our next topic, graphical misrepresentations of data. So sometimes graphs can be misleading or deceptive based on these different errors that could be done on purpose or not. Inconsistent scale, you're not counting by the same thing. One bar goes from 0 to 3, the next bar goes from 3 to 10. Misplaced origin, this is normally one of the biggest issues. The baseline should be 0. So if we go back to our apple, here your baseline is at 95. But if we change this down to 0, then the graph may not look as drastic as you see here. So that's what we mean by baseline not being at 0. Misrepresentations of data, you plot points incorrectly, your data is incorrect. Using 3D graphs or pictogram, these are harder for people to read. So if you want more examples besides the ones that are given in your book, I have found a website and the corresponding YouTube video where someone has gone out and actually found in the media where graphs have been published incorrectly. There's also a book, How to Lie with Statistics, that in 1954, we had the same problems with producing graphs. And if you're a Twitter fan, go to Twitter, stats fail. You can see lots of examples of where statistics is misused.